Okay, so this will be an analysis of the Remco's malware sample remote access tool, RAT, using the newly provided source code Ghidra from NSA. Inside of the environment of the Flare virtual machine that is provided by FireEye, so this is a pre-built malware analysis system provided by the folks at FireEye. When you log into the environment, so what I have here is the instance of Flare, and I'm using this virtual machine inside of the VMware Workstation hypervisor. When you first log on, this is the default background that you'll see on your desktop, just giving you information about the operating system and also information about licensing and creating snapshots. This particular version of Microsoft Windows 10 is provided by way of Microsoft's development website that makes available 90-day virtual machines for testing purposes. This particular enterprise version of Windows 10 is currently available for 81 days. I downloaded it several days ago. And what I'm going to do, as you can see here in the instructions, this again is the default desktop background provided by Microsoft, is create a snapshot for two reasons. Number one, it basically freezes time so I'm not losing the operating system at the 90-day mark. And then number two, just as a good practice, I'm also establishing a snapshot prior to infecting this machine through the code analysis when we launch the sample inside of the Ghidra disassembler. So to do that, and again, I'm using Windows-based VMware Workstation. I'm going to go up to the VM menu and I'm going to grab a snapshot. One of the things I'll note here, if you don't want to keep this background on the desktop as a default, if you want to customize that, on my particular system here, inside of the pictures folder, and what can be distributed to you all is just the Flare logo or Ghidra. And again, just to break this down again, Ghidra is the disassembler program, much like IDA Pro that we're going to use, but it's newer. It's was developed and the source code by the NSA, and this was provided via public release. Flare being the virtual machine environment that is just chock full of custom tools built by FireEye, but also some household names as well. But I can choose either one of these as the background logo. I'll just right click on the Flare logo and I will set that as my desktop background. Now at this point, if I look around the desktop, you'll see an infected folder. On this particular VM, not much there. There are some malicious PCAPs there for later testing that we can look at. And then also, this is the malware sample Remcos that we'll look at today in this webcast. So that's still password protected and zipped up. If I go out to the folder here on the desktop labeled Flare, I will see all of the different tools categorized. And then also on the desktop, I have already installed Ghidra and placed a shortcut for the bat file, the Ghidra run.bat. So I'm going to go now and create the snapshot. And I will just call this snapshot 4. And in this instance, because I had other snapshots that I had created, I will just call this pre, or actually I'll call it clean, Ghidra installed. That way it gives me something as a note to reference back to in case I need to revert back to another snapshot. And then desktop wallpaper customized. Now, I already have several snapshots. This might be your first one if you're doing this the first time, so you will have it as snapshot 1. And And then if you needed to revert back to this snapshot post-infection to revert back to a clean snapshot, you would just go back to VM, snapshot, revert to that snapshot 1 or whatever you numbered there. Just a good practice, again, to have the snapshots in place in case you need to go back from changes that were made, or in the case of looking at things like ransomware that might seize up your system, having a snapshot to go back to. So the actual malware analysis here in the sample, giving credit to the folks at Threat Vector from Cylance, providing the sample, Anuj Soni, part of the Cylance Threat Vector team, and then also providing the written methodology here that can be found on the Threat Vector Cylance blog. So when we look at Ghidra, we compare this to other tools that maybe we have used in the past, such as IDA Pro. So Ghidra, again, is the free software reverse engineering framework developed by the NSA, and it was released as open source software back in March of this year. Now, you can also go out to the NSA's GitHub page as well for information pertaining to Ghidra, where they address bugs and questions and enhancement requests regarding Ghidra. And Ghidra continues to grow in popularity, and there are a lot of folks in the industry that are contributing to the Ghidra project as well. So the first thing we want to do is take a look at the executable. We want to load the executable into Ghidra. Before I open up the Ghidra program, I'm going to go to the infected folder here on the desktop. And this 9B93, I'm going to right click on this. And I'm going to use 7-zip, which is pre-installed, to extract these files. Extract here. And I'm going to use the password infected, all lowercase. And just keep in mind that this is a real-world malware sample. So at that point, I'm going to now run Ghidra. And at startup, you'll see that there are tips of the day that you can go through, or you can disable that function here by clicking the box. I'm going to maximize this window. So I'm going to go to File now to start a new project. And you have two options here. You can do shared or non-shared. If this was a single user analysis, which for the purposes of this demonstration, we will keep it as non-shared. If it was shared, that would be for environments for collaborative work where multiple users can access a project repository, maybe on a server environment. So I'm going to select non-shared. And I need to assign a project directory. So I'm going to go up to the root of C, create a new folder, and I'm going to call it Ghidra Projects. Select that project directory. And the project name is just going to be the name of the malware sample, Remcos. And hit finish. So now I have a working directory for the actual project for our analysis here for Remcos. So again, Remcos is the remote administrative tool, or RAT, sold by the breakingsecurity.net. And so what this can do is monitor and control an infected machine. So at this point, I want to go out to the folder on my desktop infected. And I want to take the sample here and I want to drag this over to my active project window. And once I do that, the sample will import and give me some options here with this dialog box where I can accept the defaults. Now this will take some time to import the file, anywhere from 3, 4, 5 minutes depending on your system and the size of the sample coming in. So I'll pause the video here and we'll come back once the sample has been imported completely. Okay, so at this point I'm going to allow access. This is just Windows Defender popping up. There are some customizations that have been made inside of the Flare VM distribution for Windows Defender. And this prompt here, I'm going to allow access. And what we're left with is a summary information of the actual sample itself, everything from the program name that we saw earlier in the directory down to the memory blocks, the compiler that was used, and also MD5 hash values. So I'm going to exit out of this. So at this point, I want to get to the code browser, so I'm going to double click on the actual file here that we've imported, the Remcos. And before I start doing analysis manually, I want to go in and start making some adjustments to some of the settings here to make it a better working environment. And this is certainly up to you as to how you want to set up your environment so far as customizing fonts. So the first thing I have here is analysis options, and I want to scroll down and select this propagate external parameters. Okay, and this is going to populate the arguments or the function arguments in the comments when I'm going through the actual analysis process. So I'm going to propagate external parameters and click Analyze. And so that'll work in the background. So this gives me some time now to modify some of the things concerning display. So what I'll do now is go up to the Edit menu at the top and go to Tool Options. And under Options here, one of the first areas that I'm going to take a look at, and again, this is all customizable based on what works best for your environment, but these are just suggested environments changes that you may want to consider. So I'll go first to Listing Display. And I'm going to set mine to bold. So here you can increase the font size and enable bold formatting. And what I like about the Ghidra setup here is it gives you a nice output preview as to what it's going to look like when you start doing your actual code analysis. Now just before the listing display, if you go up to Byte Viewer, you can actually select the various colors for separations for blocks, and then also your highlight function as well. So currently it's a light grayish blue for your highlight cursor, and I'm going to switch that to a yellow. If we now go down to, or back to listing fields here, I'm going to maximize this. And when I go to the bytes field, I'm actually going to limit the maximum lines to display just to make it easier to hone in on the spacing of the assembly code. So I'm going to simplify that down to maximum lines to display. I'm going to set that to a value of 1. Hit apply. And then under listing fields, I'm also going to go to the cursor text highlight. And my highlight color is yellow. And I'm also going to operate the mouse button to switch to left, which is consistent with other disassemblers. So that will highlight all instances of the selected text when you use the left mouse button. And then also under listing fields, EOL comments field. I'm going to use the semicolon option. This just better separates the assembly text from the comments that are inserted. And then finally, under listing fields, go to operands field. And I'm going to check add a space after separator. Just makes it a little bit easier to read, and hit apply. And then OK. So as we start jumping into this, one of the first things we may want to consider is references to APIs. So as we take a look at API references, there's different ways we can do that within Ghidra. One of the first ways we can do that is by going up to the window menu here and selecting the symbol references submenu. Now, this particular area includes more than just our imports. If I look through this, I can select APIs that stand out and identify where that function is called. So I can sort through these. And some areas that we may want to look at are registry modifications or processes that are possibly being created. So I scroll down to the area that says create. I'll expand this particular column. And I can see here create process A. And we'll hone in on this one because this is actually showing us potentially additional processes that this particular Remco's program is spawning. Now, if I want to locate a reference to that API, once I do a single click, you'll notice that to the right there, on the right-hand side there, that we have further information that is given to us where we can actually click on the actual API name. So I'm going to click on the second one here, 40A0DA. And once I click on this reference, it's going to actually populate the listing for us. Okay. That'll bring us back to our listing view. Now we may have to move some things out of the way. So I'm going to close out of the symbol table. And you'll see now that the listing view populates with the disassembly language. Now, if I look at this virtual address 40A0DA, I can actually begin to look at the call to create process A. Now, up before that, there is a push instruction just above, and we can actually see that there is a call for, or a push for, a command.exe. Okay, so the call refers to the create process A's argument. So on the right, we see these auto-generated comments. So we see the push system32, so we're looking at the command prompt, and then we move over and we actually see auto-generated comments that identify the function parameters. Now, these particular function parameters are described further on Microsoft's website. So if you go out to Microsoft, there's actually a complete list of the function parameters. You can actually Google that, the Process Threads API, on Microsoft's website, just to have a better understanding as to what these various parameters mean. And this is our process creation flag. So docs.microsoft.com, and these are the process creation flags, more of a master key, if you will. Now, if we take a look at the creation flags, going back to Ghidra here, these DW creation flags that we see, they specify the process creation flags, which is indicative or characteristics of the spawn process. Now, if we go up and we take a look at various values here, namely this hex 8 followed by 1, 2, 3, 4, 5, 6 zeros, that represents a symbolic constant. So what I can do here is convert that into something that makes more sense to us, and deciphering what it is that's actually going on here makes it more human readable. Is I can click here, right click, and I'm going to go to the sub menu, set equate, which gives us options for that chosen hexadecimal value. Now, if I want to identify the correct choice for this, most of the process creation flags, when we look back at that Microsoft website I just showed you, begin with that word create. So I can start typing in create, and the only one that populates here is create no window. So I can click this, make sure I'm applying it to the current location, click OK. And this flag specifies now that the spawn process should not launch a console window and is likely the correct choice here. So now if we want to take a look at the decompiler output, and this is one of the great things about Ghidra is the built-in output, is it displays the high-level C representation of assembly. So if we want to highlight the call to create process A, what we now want to do is allow this to drive the decompile window, again located on the right here. And this allows us to decipher more of what's going on. Now, certainly the left-hand side here to an experienced analyst with assembly may be good to go. However, this far right side on the decompiler output, it's much easier for us to understand the analysis as to what's going on. If we go over to the right, we can see the system32, command.exe, and then we also see what appears to be an adjustment or a change to a registry value under the software hive. And we see these LP security or LP attributes as well. Now what's interesting about this is that the decompiler output stays in sync with the changes that are made within this listing view. And this would explain why the create no window appears as an argument to create process A in the C representation. So any changes that are made to the function, the variable, the argument names in either the listing or the decompile view will update on this other window here to the right. So if we again take a look at this code, we discovered attempts to disable the user account control by modifying this LUA values that we see. Okay. And let's again follow that Microsoft Windows current version policy systems, and you have to expand this right side decompile window to see a little bit further. But we see the modification of that registry key. Now another approach is to identifying the malicious code here is following references to suspicious strings, which we may be familiar with. So we can actually take a look at strings embedded here within the target file by going back to the window menu, and then from there we'll go down to define strings. Now this particular sample is not obfuscated, so there are some strings that we would be able to see in plain text. So if we scroll down the strings here, just take a moment to observe actually what's going on. And I'm going to expand out the column on the string value. So I see something here, 414C44. So we see a control V, so we see a paste from the clipboard. So I might want to look to see if there's any type of copy, and I do. If I come down to 414CCC, I see indications in the string value that there has been text copied to the clipboard. And as I click on this, again, this is an indication that the malware is copying clipboard text as maybe surveillance. So think about everything that you would, control copy to paste into maybe a website, or if it's a password or credit card information, what have you, sensitive data. Now, I want to confirm this. I can actually browse to a reference to this string within the actual code. So I click on that row associated with it. It takes me to that in the listing window with the data, and we see the address there. Again, just matching it, comparative analysis, 414CCC, here in my listing window. If I scroll over, following text has been copied to the clipboard, and this identifies the references here that we see in blue. Now, if I want to see where that's leading to, or the references, so we're doing some cross correlation here, I'm going to right click, go to references, and on the references, I'm going to show references to that specific address. And I see only one reference to that string. So clicking on that single references takes us to the hex 406 AF8, located in the function with label, as we can see there, is actually fun, FUN 00 or underscore 00406 A6F. Now, if I scroll through all of this, there may not be anything that immediately jumps out. So I may not be able to determine if it's in fact responsible for capturing the clipboard data. So one of the things that I can do is I can actually bring up a graphing function, going back to window, and I can actually do the function graph, or the function call graph, just to get a better understanding as to what's going on. It's displaying the relationships between functions and providing a high-level overview. So by going through this interface, we can discover that call to fun underscore 00406 A29. Expand this out. It does in fact open clipboard, get clipboard data, close the clipboard. Okay, so this is giving us a understanding that the execution of the window APIs that allow the malware to collect clipboard data. Now, if I want to dive into this further, I can click on the function label with that name and view the listing or decompile windows. Now at this point I can press the G key and go directly to that label name or address and click OK to jump to the actual code. That's an alternative as well. And one of the things that I like to do is actually see a visual representation of what's actually going on here within the actual function. So I can go back to window and go to function graph. And when I take a look at the function graph, I'm able to see these individual code blocks, and this may look very similar to IDA Pro in your experience. And here I'm able to see the arrows representing conditional and unconditional jumps. So in this first block of code, we can see a call to open the clipboard. And this is followed by test, and then we can also from there see a jump to 0 or JZ. And so these evaluate the return value stored in EAX. The JZ or jump to 0 or jump if 0 instruction indicates that the execution should jump to 406 A55 that we see here. if EAX is a 0. So return value of 0 means the call to open clipboard failed. If EAX is non-zero, the call to open clipboard succeeded. So in this case, the jump will not be taken and the execution will flow to the code block on the right that we see, where additional API calls were made to obtain that clipboard data. So if the clipboard opens successfully, it obtains its data. Otherwise, it says don't execute the code to gather the clipboard information. So it's a test to see if the clipboard itself would actually even open successfully. So the execution, and this is a very neat feature of Ghidra, the execution follows the green arrow that we see here. So if the condition EAX is 0 is true, execution follows the red arrow if the condition is false. So if it's true, it will follow the green. If it's red, condition is false. And you'll see these hover points here, just gives you a more granular view for each block of code. One of the last things to note within Ghidra is it does support custom scripting such as Java and Python. So I can go, I'm going to click out of the function graph here. I can go to Window and I can actually go to the script manager. So if your language is Python or Java and that's your experience, or you want to practice writing scripts, you can do that. There are 200 or so scripts already built into, but you can always go in and add new as well to the top right, create new script. So I hope you'll enjoy the use of Ghidra and the Flare virtual machine environment in your future task or lab environments or course of analysis for your projects. I do invite you to take a look at the GitHub site, along with, if you're on social media, taking a look at the official Ghidra Twitter account at Ghidra_RE, and then also keeping up with what's being published on GitHub by the community.